Okay, so today what we're going to do is we're going to learn about what are called complementary events. And then we're going to learn how to calculate them. Okay? So I'm just going to walk you through an Education Perfect lesson, and anything that I write down, and in some cases I might just underline some things because they've already written everything down. There's no reason for me to rewrite it. I'll underline it. Needs to go in your notes, right? Then when it comes time to working the steps, then I'll write the steps 1, 2, 3. So your introduction or your main idea is the idea of complementary events. And complementary events can simply be summed up as everything that can happen. Okay? Right? So, everything that can happen. Sounds a lot like the sample space, but you're going to see that's just a general idea of what we're going to be looking at. So let's go to the lesson and talk about and look at their idea of complementary events. Okay? So, think about what is it we call the outcome that isn't what we're looking for. Okay? So a while ago we wanted 2 6s, yeah? Somebody wanted 2 6s. Well, what about the other stuff? That's the stuff we're not looking for. And the stuff we're not looking for is called the complement. Okay? And you're going to see that word quite a lot. So you don't have to worry about writing it down yet. Here it is. Okay? So, when you're talking about the complement, so there's your word, of an event is all the outcomes that are not the event. Okay? So all the outcomes that are not the event. Okay. So, if we flipped a coin and the event we got was a coin landing on heads, the complement of it would not be a heads. Well, what's a not heads? Landing on tails, right? So, this is an example that you can write down. So, here's an example. If the event is landing on heads, the complement would be landing on tails. So there's your example. So if you think about it, every outcome, so this will be in your notes, not an example, but in your notes you should write this. Every outcome of a trial will be either the event or its complement. Okay, so now that we know what a complement is, what we're going to do now is we're going to learn how to calculate it. Because we are usually dealing with not just a list of events. What we're usually talking about is we'll have the probability of an event. And we want the probability of it not happening, right? Complement is simply the probability of it not happening. So let's just look at how we can calculate probabilities. Right? First, we're going to add some probabilities of events and their complements together and see if you notice a pattern. So look at your coin, for example. Right? And you don't need to write this in your notes. We're just going to look at this example. So our event, when you're flipping a coin, is landing on heads. So the complement of landing on heads is landing on tails. Yeah? So we've got those two events. What we want to explore is what would happen if we add those probabilities together. Well, let's look at the two probabilities and think about it. The probability of getting a heads is 1/2, or 0.5, or 50%. Remember, probabilities can be written in one of 3 different ways, and pay close attention to which one they want you to write, because if you write in the wrong one, right, if we want a percent and you put in a fraction, it's not going to be right. So let's just use the fraction, 1/2. The probability of the complement, which is a tail, is also 1/2. What would you get if you add 1/2 and another 1/2? 1. Yeah. 1 whole. Yeah. So you get 1. And that is always true of complements. So in your notes, you need to write complements plus events always add together to equal 1. So a complement plus an event is always going to equal 1. So if that's true, then I can, if I know the probability of something happening, then I can easily find the probability that it's not going to happen. Because if you think of it in percents, for example, what is the probability of something definitely happening? 100%, right? And what if I say, for example, the probability of an event is 60%? Well, if every possibility is 100%, and the probability of having the event happen is 60%, how can I find out what's left? What operation would I use? Exactly. I would just simply subtract them, which gives me 40%, and this 40% would be the complement. So, to find the complement, okay? So if you're in your notes, to find the complement, when you know the probability of an event, well, it's really just one step, so don't really need steps, do we? Just subtract the probability of the event from 1, or 100% if you're dealing in percents, right? Because it can be written as a number or a percent. So if it's written as numbers, a fraction or a decimal, you simply subtract it from 1. If it's written as a percent, you would subtract it from using percents, okay? So either 1 or 100%, because 1 and 100% mean exactly the same thing. And again, don't panic about this, because remember that you're allowed to use your calculator. So if it's a fraction, you just put in 1 minus and then enter the fraction. If it's a decimal, just put in 1 minus and enter your decimal. Okay? But what would happen if I put that in and I got a negative number? Is that a good thing? No, that means I've done something wrong, because remember that the lowest probability you can get is always what? 0. Yeah? Okay? So be careful. What would happen if I had put them in and I got 1.5? Is that a good thing? No, because probability can never be more than 1, right? So keep in mind, when you do these on your calculator, you're going to be giving up some of your control. So you always need to look at your answer to make sure that you entered the correct thing, etc. Don't just read what the calculator says and say, must be that, because the calculator says it is, right? Okay, be careful. You can hit the wrong buttons, etc., so it will make a difference. Okay? So if you know the probability of the event, then you just subtract it from 1. What if I know the complement of the event? Could I find the probability? Sure. How? Subtract it from 1. So you would just take the complement, subtract it from 1, and that would give you the event. Right? So it's the same process for both. Okay? All right. So there you go. They were showing you that. So 50% plus 50% is 100%, or 1. Or 2 over 2, or 1. Same difference when we added those two together. All right? Okay. So here, you can see the event and its complement. Together, they cover every possible outcome. Right? That's where we started with. That complements together with our events. All of it combined together cover every possible outcome, which is also known as something else. What is it if you make a list of every possible outcome? What's it called? The sample space. Excellent. Remember those terms. You're going to use them a lot, so you might want to study those terms. Good. So, probability of an event and a complement always add up to what? 1. So you can always find 1 by simply subtracting the other from 1. Yeah? Pretty easy, yeah? Let's see. Lucy wants the spinner to land on 1. It has a probability of 37.5. What is the probability of the complement? Okay. All right, so I want to just show you a little notation for this. So notation for complements. Right. So if you have the probability of E, okay, is something, that's the probability. Okay? Well, if you want the complement of E, then what you're going to do is exactly the same notation, but next to that P, you're going to have a little apostrophe next to it. And that apostrophe stands for complement, because you don't want to have to write complement of every single time, right? So instead, you can just write complement. So for example, if I have the probability of E is 40%, then the probability, and this is read as the probability of not E, that's what that little apostrophe says. The probability of not E would be 60%. Instead of having to write out the word complement every time, you can just use this notation. You don't have to. You could write complement if you want to, right? But you can use this notation instead if you want. Yes?